This is a video on evaluating functions. So you can see that I have three different functions here. And I know they're functions because I'm using function notation. We have a name of the function, in this case f, and its independent variable x. Altogether, this is the dependent variable. Okay, so if we look over here, this is telling me, okay, f parentheses -2. A lot of people see that as -2 times f. That's not what it means. Okay, this is saying what is the value of function f, or if you prefer at this point to call it an equation f, when the independent variable equals -2. Now that's a lot to say, all right? But notice that what we have is f of -2. This -2 takes the place of the x. So in my equation, wherever I see an x, I'm going to replace it with a -2. So what that's going to look like, okay, I'm going to rewrite f of -2 here. You can see that x is going to be replaced by -2, so it's 9 parentheses -2 squared minus 2 times -2 plus 3. I've successfully replaced each x with the new input. Okay, let me fix that -2 there. Kind of blended together. Once you do that, the rest of the process becomes order of operations, which hopefully at this point you're comfortable with. It does tend to get some people sometimes, so just be aware. I'm going to go through that, parentheses. So I'm going to do inside the parentheses. There's nothing to do inside the parentheses. Okay, let's do some exponents. The only exponent I see is this squared, and squared means multiply the number by itself. So -2 times -2 is 4. Okay, again, referencing my PEMDAS, there's no more exponents. Now I'm going to multiply. So I'm going to multiply 9 times 4, which is 36. I'm going to multiply -2 times -2, that's plus 4. And plus 3. There was no division, so I'm done multiplying, I'm done divide. And then I'm going to add and subtract. Well, I only see addition in this problem. So I'm going to do 36 plus 4 plus 3, which gives me 43. So f of -2 is equal to 43. That is the answer. We're done that problem. Okay? Now what that means is that if we were to graph this, which we're not going to do today, but if we were, the point -2 comma 43 would be a point on the graph of f. So if you had the graph of f in front of us, we could find that point. Again, that's not super important right now, but it does kind of connect things. All right, so the answer for that first one, f of -2, excuse me, is 43. So using that, let's take a moment here. You should pause. Try plugging in 3 into g. So we're going to find g of 3. So just plug it in, pause, and then restart your video. When I do that, I get 1 over 3 plus 4. Okay, so this x was an x here. It turned into a 3 here, so I turned the x into a 3 here. Okay, I'm going to highlight that. X becomes 3. From there, I don't see any parentheses. I don't see any exponents. I see 1 divided by 3. If I want to deal with decimals, I can, but I'd rather deal with fractions. And I can't add fractions with different denominators, so I'm going to change the 4 over 1 into, I'm going to multiply by 3 over 3, which is going to give me 12 over 3. And when I add the numerators, I keep the denominator, and I have my answer. G of 3 equals 13 over 3, which means that the point 3 comma 13 over 3 is on the graph of G. Okay, again, we had an input, we did all of this work, and we got our output. It's all about understanding input and output and the process in between. One more example. Now, if you're in Algebra 1, this equation is probably much more comfortable for you. The last value that I have to put in here is 6. So h of 6. So here's function h. Okay, and they want us to find h of 6. So go ahead and plug that in. X here becomes 6. Pause. Try it. Result, 2 over 3 times 6 plus 10. And again, order of operations. Parentheses, none. Exponents, none. Multiply and divide. Well, here's a multiplication problem. And I know some people will get confused here. So what I would do is I'd put a 1 under the 6. Now I have fractions multiplying each other. So I'm going to do top times the top, which is 12. Bottom times bottom, which is 3. Now I could try to find a common denominator, but it's probably better to see if you can reduce first. 12 divided by 3 is actually just 4. And when I add the 10, I get 14. So my input was 6 and my output was 14. So that would be the point 6 comma 14. Again, each of these 3 equations are functions. They have different names, f, g, and h. And each of those points are on a different graph. But that's evaluating functions. You plug the number everywhere there's an x, and you use the order of operations to find your output.